Have you ever had a bad experience in math? I think probably most people have. Does anybody still think to this day that you're bad in math? Raise your hand if you think you're bad in math. People expect me to be reassuring now and say, oh, you're not really bad in math. But guess what? I'm sure you are. Now, if you think you're bad in math, you're bad. Now, the question is there anything I can do? Is there a way I can teach math that'll make it better? Now, this is what I do. Okay, I've written children's picture books. I write math games. I create games with my son, with my wife. And we're trying to figure out better ways to do math. And then we're trying to trick kids into practicing. Okay, can I trick a kid into wanting to do thousands, tens of thousands of repetitions to get really good? Now, let's start. I'm going to go over 3 ideas today to try to see if I can make math better for you. Ready? These are the 3 ideas. Visualization. Do you think it'll help kids if they can visualize the math first before they start doing equations? How about if they stopped and tried to make sense of it? Instead of grinding through equations, what if they actually just sat there and went, I wonder what this means. I wonder what I could do with this problem. Then the last thing, number sense. A lot of kids don't have number sense. So the question is, what is number sense? Can I develop it? So let's start. Let's start with visualization. I'm going to start with a problem that I hope brings back a flood of bad memories. Okay, ready? So this is 6th grade. We're not talking high school. I'm not even really talking middle school. This is 6th grade math. Now, if you look at that problem, 27 is 3/4 of what number? Can anybody remember how they did that as a kid? We translate, literally. We look for keywords, and we translate into symbols, then we try to solve for x. So when I see the number 27, what would I always know to do? Write 27. What did is mean? Was that equals? So you write an equal sign. 3/4, is that a number? Yeah, I write the number. Then what? Of. What was that code for? Of. Multiply. So I multiply. What number? X. And if I can do that, I have this equation. Now I simply do what? Solve for x. Okay, so what's the key to solving that equation for x? I look at that 4 in the denominator. I got to get rid of it. How am I going to get rid of it? I'm going to multiply both sides by 4. So if I multiply both sides by 4, won't those 4's cancel out? Oh, that's nice, because now what do? I can say, well, 4 times 27 is 3x. People feeling bad yet? Okay, that's the goal. Okay, ready? So I got to get x by itself. So what do I have to do? Got to divide both sides by 3. Oh, that's nice. The 3's cancel. 27 divided by 3. Isn't that just 9? Oh, so what do I have now? 4 times 9 is x. 4 times 9? 36. 36 equals x. Did anybody for 1 second actually make sense of the equation, or did you just do the same thing to both sides? It's pretty much procedural. Let's do it a completely different way. Ready? Start with a blank page. Let's make sense of it. Okay, so I look at what number, and I can still call it x. The only difference is I'm going to draw a picture of it. So I'm going to draw a bar, and I'm going to say, see that bar? That's the number I'm looking for. I don't know the number, but what does the problem tell me I know? I know 3/4 of it. Can you picture in your mind 3/4 of that bar? What would you do to the bar? Would you first cut it into 4 equal parts? There they are. How many of them do you know? 3. Oh, I know that many. How much is 3/4? 27. Now just look at that picture. Do I need to do anything else? Or are you already figuring it out? What do you think those 3 pieces are if they're all the same size and they total 27? Aren't those all 9? But if those are 9, what can you tell me about that last piece? It's 9. Isn't x 36? Now, that's the way we did it. So you look at that, and then you look at that. Now, here's the question. Are you feeling some weird sense of satisfaction? And you don't even know why? Okay? So, do you want to do another one? Yeah, let's do another one. Ready? Let's do 30 is 2/3 of what number? Well, what can we do again? We can say, I need to look for some number. Let's call it x. I'm going to draw a picture of it. Oh, I don't know x, but I actually know what? 2/3. So I'm going to divide that into what? 3 equal parts. How many do I know? 2. Oh, how much is 2 out of those 3 parts equal? Oh, it tells me 30. What are you thinking right now? Haven't you already figured out x? You've already figured out x because you know those 2 parts are what? 15. What that means, the last one's 15. So x is what? 45. Now you hear all this stuff about math. Oh, there's new math. Turns out new math was 1970. Okay? So that was a long time ago. But people are still calling it new math. Then the Common Core came along and people are like, oh, it's terrible. It's just simply trying to do what? Move kids from doing things very procedurally, where they don't understand what they're doing, to trying to make sense of it. Now, do you think you could do that whole process in your head? I bet you can. We're going to move from seeing math to visualizing it in your head. Ready? Here's the problem. 16 is 4/5 of what number? Stay with me. Ready? Here's the number. Do you know the number? No. So what are you going to do with that bar? Divide into what? 5 equal pieces. How many of those pieces do you know? 4. How much is 4 of those pieces? 16. So what's each of those pieces? 4. But I don't have 4. I actually want 5. What are 5 4s equal to? 20. That's the answer. Is that weirdly satisfying? Okay, ready? So let's just do it out. Here's x. Okay, because we want to make sure we did it right. There's x. I divide into fifths, 5 equal parts. They said, I know 4. 4 of them was 16. So each of those parts is 4. The last one's 4. It's 20. Now, can I make this even better? Ready? So that was about visualization to help me understand. The next part I'm going to talk about is reasoning. What if I literally tried to make sense of what I'm doing instead of just trying to remember what somebody told me to do? When people try to remember, like they told me here when I did this TED Talk, they were like, oh, you got to memorize your speech. And I said to myself, if I have to put my brain power to remembering what to say, I'm going to be a train wreck. The only way I can give a speech is to do what? Actually just explain what I already know. So I'm using all my brain power right now to just do what I know, not trying to remember. Now, let's talk about reasoning, making sense. I don't want you to remember what to do. I want us to figure it out. But first, let's make it bad. Let's bring back bad memories. Okay, ready? 3x plus 4 is 28. I'm watching my kid Katie do this in middle school. She follows directions. What do you think they told her to do? You got to get x by itself. What are you going to do? Subtract 4 from both sides. Oh, that's great, because why? 4's cancel. Now what do you see? 3x is 24. You got to get x by itself. What do I do? Divide both sides by 3. 3's cancel. Oh, look at that. X equals 8. Katie's like, Dad, I got that right. Yes, she did. Did she ever think about what that equation was telling her? Never. I said, Katie, try this. Here's the way we did math. Ready? Look at that equation. I covered up the 3x. And I said, just look at that equation. Could a first grader figure that out? Yeah, you know what that's called? A part-whole problem. Some number plus 4 is 28. What's the number? Isn't it 24? It's the only number that's going to work. We're thinking 24. It's got to be a 24. Well, guess what? It's 3x. 3 of something is 24. 3 what's is 24? 8's. X is 8. That's making sense of an equation. Now, let's make one worse. Ready? Because it always gets worse. Right when you think you got it, it gets worse. Okay, ready? So there we are. That's worse. Okay, so what do they tell us to do? Subtract 4 from both sides. 4's cancel. Oh, now I got 2 times x minus 3 equals 14. I got to get x by itself, so what do? Divide both sides by 2. Oh, that's great. The 2's cancel. Oh, 14 divided by 2 is what? 7. X minus 3 is 7. What do I do now? Add 3 to both sides. 3's cancel. X equals 10. And if you're good and you grind through these, you get good grades. It doesn't mean you understand what you're doing. So let's make sense of it. Ready? There it is. Let's focus on the mess right there. What does the mess have to be? The only way that's going to work is if that chunk is what? 14, because 14 plus 4 is 18. So we know that's got to be a 14. But think about what it's really saying. It's saying 2 times a smaller mess is 14. So what's the smaller mess have to be? Doesn't that smaller mess have to be 7? Well, if that chunk is 7, what does X have to be? Doesn't it have to be a 10? Because 10 minus 3 is 7. Did we just solve that problem just thinking about it? That's all we do. Okay, so again, you can look on the left. If that appeals to you, do it that way. Okay, but if you start to think about math, the stuff on the left that you do have to learn to do by high school and when you get to higher math, you have to learn that, but it starts to make sense. Now, what's the bottom line? Understanding, visualizing helps a lot. So let's talk about number sense. Okay, how do I get kids to be good with numbers? So let's start with an easy problem, 8 plus 6. How do kids learn to do 8 plus 6 when they're little? They count. First they go 1, 2, 3, 4, 5, 6, 7, 8. And then they go 9, 10, 11, 12, 13, 14. And they go 14. And you know what we say to them? Oh, can you count on instead of counting everything? And they learn to go like this. 8, 9, 10, 11, 12, 13, 14. And is that better than counting everything? Yeah, but they're processing that 6 as what? 6 ones. Now, will that work for a while? Yeah, it will. And then the numbers start getting big, and it doesn't work as well. And then by 4th grade, we start doing what? Fractions and decimals. Doesn't work well. So what we teach kids to do is, can you think about numbers in smart ways? Instead of thinking about that 6 as 6 ones, break it into 2 easier pieces. What are the 2 pieces? 3 and 3. Everybody agree it's 3 and 3. No, it's not 3 and 3. Why not? Does 8 go well with 3? What does 8 plus 3 make? 11. Wouldn't it be better to make a 10? So how would you make the 6? So when I add it to the 8, I can get to a 10. I just think of the 6 as what? 2 and a 4. Because then isn't 8 plus 2 10? And then what's the 10 and a 4 called? What's the name of a 10 and a 4? 14. That's the answer. So we're trying to get kids, they can count at the beginning. It's fine to count on your fingers when you're little, but you got to move away from it. And then the question is, if I let a kid count too long without moving them away by giving them an option, it becomes ingrained. Okay, now let's do another one. Easy. 7 plus 5. The question is, what's the 5? Isn't it a 3 and a 2? So if you thought of that 5 as a 3 and a 2, would that make it easy to do? Yeah. What's 7 plus 3? 10. What's 10 plus that 2? 12. There's no counting. So we're breaking numbers apart. We're thinking about numbers in smart ways. Now, let's apply that. That was easy. Let's go to a harder problem. Kids hate subtracting across zeros. I think you will too. Ready? Okay, I think you will too. Okay, ready? So I give you that problem. Let's use the traditional algorithm. All the people that don't like so-called new math that's like 50 years old, you know what they want? Standard algorithms. To like, just teach my kid the way we learned it. Okay? I say, okay, I'll do that for you. Ready? What do you do in a problem like that? Oh, you go to the ones place. There aren't any. Oh, what do they tell you? Oh, just go to the tens place. You need to borrow a 10. Well, I look in the tens place and there aren't any. So what do you have to do? You got to go to the hundreds place. Then what? Cross out the 8, make it a 7. Cross out the 0, make it a 10. Cross out the 10, make it a 9. Cross out the 0, make that one a 10. Did I even do that right? No. Did I? Yeah, see, you don't even know, do you? Now, it turns out I did do that right. Okay? I did. But could there be a better way to do it? Well, let's see. Ready? So what do I do? That's the answer. It's 453. But is there a better way? Well, let's see. There's the original problem. I thought this was clever. Ready? Think out of the box. See how the box disappeared? I came up with that this morning. Okay, ready? Think out of the box. Ready? So what do I do? This time I say, oh, let's go to the ones place. There still aren't any ones. Go to the tens place. Guess what? Are there any tens? So what's better about that? Nothing. But wait. Ready? Then I ask you to look at the number like that. All I did was put a line there. How many 10s are there? Does anybody see 80 10s? Turns out, there are 80 10s in 800. And you thought you didn't have any 10s and you got 80 of them. You only need one. Okay, so what do? I can just cross out the 80 and make it a 79, one step. Then I move that 10 over. Now can I do the subtraction? Yeah, it's a one-step problem. It's 453. All I did was ask you to think about that number in a smarter way. Let's do one that's really bad. Ready? Mm-hmm. Is there a lot of regrouping when you do this? You go to the ones, you go to the 10s, you go to the hundreds, cross out the 1,000, you come this way, and you have to work your way backwards. Ready? Are there any ones? No. Are there any 10s? How many? How about 100? There's 100 10s and 1,000. So guess what? Cross them out, just take one away, you got 99 10s and 10 ones. Is the problem easy to do now? It's 721. Now, you ready to think way out of the box? Way out of the box. Ready? All the people that think you're really good in math, raise your hand. Yeah, maybe you are, maybe you're not. Ready? Let's see how good you are. Ready? I need you to do this problem in your head. Just yell out the answer. Go. People that love standard algorithms, go ahead. Now, is it hard to do that problem in your head? Well, let's see if the worst person in this audience can do it in their head. Who's the worst? Don't be shy. You. She raised her hand at me. She must be bad. Ready? Now, that's hard to do because you're looking at it the traditional way. Watch what I do. All I'm going to do is this. All I did is I put 2 lines in there. Do you know 4 minus 2? It's 2. What do you see next? 100 minus 75. Isn't that just 25? What's 72 minus 36? 36? That's the answer. People are like, are you allowed to do that? I just did. Okay, now, you're allowed to do that. I just did it. Okay, that's the right answer. Now, does this work for multiplication? Well, let's see. If it does, math is supposed to make sense. So let's see. I'm going to go to the worst operation, actually, before division. Kids are terrible at this. Okay, they're terrible. So I'm going to ask you, can you cut a number in half? Can you do that for me? Just cut a number in half. You're dividing by 2. Ready? Here's the number. 790. Cut that in half. Now, you know what's the number one strategy people use if you give them a hard number? What is it? They stare at it. Okay, now, how many people are literally staring at the 790 going, that's a hard number? Now, you know what they're thinking 5 seconds later? That's a hard number. Now, all I'm going to ask you to do is think about that in a smarter way. Ready? We're going to think, how can I break apart the 790? Here's how. 790. I never would have thought of that. Now, can you tell me half of 700? 350. Can you tell me half of 90? 45. What's that 350 and that 45? 395. That's all it is. You just teach kids, just think about the numbers in a smarter way. You ready for another one? 930. Oh, how do you break apart 930? What's the most obvious way to do it? 930. Oh, what's half of 900? 450. What's half of the 30? 15. Put those together, what do I get? 465. Now, here's your assessment. Am I allowed to assess you? Yes, it's my talk. Ready? Here we go. It's my talk. Ready? Here you go. Ready? 91 divided by 7. Now, if you're not so good at this yet, I go, what's a 91? You go, it's a 90 and a 1. They don't divide by 7. So then you go, it must be 80 and 11. You moved a 10 over. Those don't divide by 7. How about a 70 and a 21? Oh, that's a good one. So let's do 70 and 21. What's 70 divided by 7? 10. What's 21 divided by 7? 3. Guess what the answer is? 13. That wasn't your assessment. That is. But what's the number bond? What is the way to break apart that number? What are you thinking? 160? 160 divides by 16. What's left? 32? Well, 160 divided by 16 is what? 10. 32 divided by 16 is what? 2. Isn't the answer 12? Now, are you feeling some really weird sense of satisfaction? Now, you're not all happy because you've been thinking, you know what, Greg, I've been struggling with division my whole life and now I get it. You're actually just happy because what? Something that you thought was hard actually starts to make sense. And so many kids are choosing careers to avoid math. Is that tragic? And I'm not trying to make kids great in math so that they can go be mathematicians. I just want kids to be comfortable enough so that any subject that uses numbers, they're going to be fine with. Okay? Do you think my own kids are good in math? Guess what they went to college for? Hockey. Okay? My parents still can't believe it. Now, math is supposed to make sense. Okay? So I hope that makes you feel a little bit better about math. If you didn't feel so good about it, I hope this will get our country starting to think. It's not about, like this person says this. It's about making sense of things. And math is just one of those subjects that we can make sense of it. So I thank you very much.